Okay, we are here to wrap up assignment 29. That's your review assignment for your upcoming exam. We did previously assignment 29A. That was some naming and formula writing, and we are going to do some textbook problems now, pages 886 to 890, various problems. We'll start with number 107. Now, I'm not going to do all of these for you. I'm just going to show you how to do one from each section, or maybe towards the end I'll do an entire problem, but a lot of this you need to do on your own. Keep in mind, all of the answers are given to you in your assignment. Those answers are not simply to be copied down, but to check to see if you're doing it right. So let's take a look at number 107 from page 886. And that asks, calculate the number of molecules or formula units in each of the following masses. And we begin with letter A, and it says 22.9 grams of sodium sulfide. Now in the book they actually give you the formula. Be prepared on your exam to be given the name and you be able to write the formula. So to find formula units of an ionic compound, we first need to go from grams to moles of sodium sulfide. Now a formula unit is just like a molecule. We just call ionic compounds by the name formula units as opposed to molecules as we do with covalent compounds. Now 1 mole of sodium sulfide is the mass of 2 sodiums and a sulfur atom. Now I calculated that a little while ago to be 77.99 grams per mole. And that takes us from grams of sodium sulfide to moles. And then we're going to go from moles of sodium sulfide to formula units. And I'm going to abbreviate that as Form U. Now 1 mole has Avogadro's number of formula units. That's 6.022 times 10 to the 23rd. So we can use our calculator now, and we can calculate the number of formula units in 22.9 grams of sodium sulfide. So for this we will hit 22.9 grams. If the number is on the bottom of our conversion factor, we will divide by it. So I'm going to divide by 77.99. And then if the number is on top, we'll multiply by it. So times 6.022 EE, that means times 10 to the 23rd. We'll hit enter. We're allowed 3 significant figures here. 22.9 has 3 sig figs. So I'm going to round my answer off to 1.77 times 10 to the 23rd formula units of sodium sulfide. Okay? And the rest of problem 107, same thing. Okay, you're going to go from grams to moles, and then you'll multiply by Avogadro's number to get the number of molecules or formula units. The next problem is number 115, and we'll do the letter A from number 115 as well. And that one says calculate the mass of the following amounts. And so for letter A, we have 3.00 moles of a compound called selenium oxybromide. And the formula is given as SeO-Br2. So here we are going to go from moles of SeO-Br2 to grams. And 1 mole of SeO-Br2 is the mass of a selenium atom, an oxygen, and 2 bromine atoms added together. And I got 254.76 grams in a mole. So moles divide out, and we have grams of selenium oxybromide. So we have 3.00 times 254.76. Enter. I get 764 grams to 3 significant figures of SeO-Br2. And the rest of number 115 would be the same type of problems. Okay, next up on our assignment is number 136. And number 136 asks us to write some formulas and then find the percent composition of the compound. So letter A on number 136 gives us the name nitric acid. Now on part A of this assignment, we reviewed how to name and write formulas. Nitric acid is an oxyacid that does not start with hydro, so that means we're going to have hydrogen acting as a metal with a 1+ charge bonded to a polyatomic. Now the polyatomic comes from nitric. Ic acids come from 8 polyatomics. Nitrate is NO3 negative. So the formula for nitric acid is HNO3. The molecular weight of this is the weight of a hydrogen, a nitrogen, and 3 oxygens, which is 63.02 grams per mole. Now I'm asked to find the percentage of each element. So I'm going to find the percent hydrogen, the percent nitrogen, and the percent oxygen in this compound. So I'm going to take the weight of the 63.02, which comes from hydrogen. Well, there's only one hydrogen. That weighs 1.01 grams per mole, divided by 63.02, times 100 to change it to a percentage, and that gives me 1.60% hydrogen. Do the same with nitrogen. There's one nitrogen, 14.01 out of 63.02 times 100 gives me 22.23% nitrogen. Now the last element, we can simply subtract these other percentages from 100, and whatever's left will be the percentage of the last element. So 100.00 minus 1.60 minus 22.23 will give me the percentage of oxygen, and that turns out to be 76.17%. If you add these up, we should get 100 if we've done it correctly. Okay? And that's how we do the problems on number 136. Remember, first write the formula, and then you can find the percentage by weight of each element after you've found the molecular weight or formula weight if it's an ionic compound. Okay, next up is number 162. Now for number 162, we're going to find an empirical formula. So it talks about a compound called ninhydrin. It says it reacts with amino acids and proteins to produce a dark-colored complex. It's used by forensic chemists and detectives to see fingerprints that might otherwise be invisible. And then it gives the percent composition. It says it's made up of 60.68% carbon, 3.40% hydrogen, and the rest of it is oxygen, which turns out to be 35.92%. Now you'll notice in the previous problem we had the formula and we found percent composition. Now I'm giving you a percent composition, and we're going to work backwards and find the formula. So the formula will be CXHYOZ. We want the lowest whole number ratio here. So we assume we have 100 grams of compound. If we do, that gives us 60.68 grams of carbon, 3.40 grams of hydrogen, and 35.92 grams of oxygen. We want the mole ratio. So don't forget to convert these each to moles. So we need to go from grams of oxygen to moles of oxygen, grams of hydrogen to moles of hydrogen, and grams of carbon to moles of carbon. Atomic mass of carbon is 12.01, hydrogen 1.01, and oxygen 16.00. Now I've actually done each of these calculations earlier to speed this up a little bit. You can check my work. It's easily done by taking this mass divided by that mass, and we'll get the number of moles. So for moles of carbon, I ended up with 5.052, hydrogen 3.37, and oxygen 2.245. Not pretty numbers. To get a mole ratio, if you remember from the 2 labs that we've done for this unit, we divide by the lowest number of moles. So we're going to divide by 2.245. that gives me, of course, 1 for oxygen. 3.37 divided by 2.245 turns out to be 1.5 for hydrogen. And 5.052 divided by 2.245 turns out to be 2.25 for carbon. Those still are not pretty whole numbers. So what I'm going to do is I'm going to maintain the ratio, but I'm going to multiply these by a number to make them whole numbers. So let's multiply each of these by 4. 1 times 4 is 4. 1.5 times 4 is 6. 2.25 times 4 is 9. So these are my whole number ratios of CX, HYOZ. So it's C9, H6O4. And that's what we call an empirical formula. C9, H6O4. And that was number 162. Okay, next step on our assignment would be number 171. Now 171, I believe, is a stoichiometry problem. I think this one, well, I don't think, this one's relatively easy. So I'm going to let you guys work on that one alone. The answer, of course, is in your manual. You can check your work with my work, and you can see if you've done it correctly. Let's hop down to 174. So, for number 174, let me find the right page for that guy. Sorry. It asks about acetylene. It said acetylene is C2H2, and it wants to know how much acetylene can be made from a reaction of 90 grams of calcium carbide. So we're given 90 with the decimal point after the 0 grams of calcium carbide. The formula is given. And it gives you the following reaction. CaC2 plus 2H2O reacts to form C2H2. Now that's our acetylene that we're going to be after. And CaOH2. So once again, we need to know the mass of acetylene that can be made from 90 grams of calcium carbide. So we have our 90 grams of CaC2. In stoichiometry, we have our balanced equation. Then we go from grams to moles of CaC2. 1 mole of calcium carbide would be the mass of a calcium, which is 40.08, I believe. Yep, 40.08, plus the mass of a carbon, 2 carbons, which would be 12.01 each. So it's 24.02 for the 2 of them. Excuse me. Sorry. And we end up with 64.1 grams per mole. And then we go from moles of calcium carbide to moles of what we're after, which is my C2H2. Now remember, this mole ratio comes from the balanced equation. And it says for 1 CaC2, I can make 1 C2H2. So grams of calcium carbide are gone, moles of calcium carbide are gone, and we're in moles of acetylene. Now the question wants to know what mass. So my final step is to go from moles of C2H2 to grams of C2H2. 1 mole of C2H2 is the mass of 2 carbons plus the mass of 2 hydrogens. And that turns out to be 26.04 grams in a mole. So it's all over but the final calculation. So let's move this up and take a look. We have 90 grams of calcium carbide divided by 64.1. Remember, if a number is on the bottom, we divide by it. We don't need to multiply or divide by 1, but we do need to multiply by 26.04 at the end. If a number is on top, we multiply by it. And I get 36.5616, but I'm only allowed 2 significant figures. So I'll round that off to 37 grams of C2H2. Okay, some simple stoichiometry. Then you have one more problem. That's number 191. And I'm going to let you guys do that one on your own. I'm not going to do everything for you. If you have questions, please come see me. And once again, the answers to each of these problems are given to you at the end of assignment 29. Please don't just copy those answers down. Please show all the work. And if you can do the ones on the review assignment, you should be just fine on the exam. Good luck, and once again, come see me if you have any questions. Thanks.